So, for this video, our topic is all about limits. So, when we say limits, limits suggest a boundary that may be reached or not, or possibly exceeded. So, for example, number 1. Limit 3x squared plus 2x plus 1 all over x squared plus 3, which x approaches to infinity. So, first, we will divide each term with the variable of the highest exponent or degree. So we have 3x squared times 1 over x squared plus 2x times 1 over x squared plus 1 times 1 over x squared all over x squared times 1 over x squared plus 3 times 1 over x squared. Then simplify, so we have 3x squared all over x squared is equal to 3. Then 2x squared all over x squared is equal to 0. Then 1 all over x squared is equal to 0 all over x raised to 2 all over x raised to 2 is equal to 1 plus 3 all over x squared is equal to 0. So, we have 3 plus 0 plus 0 is equal to 3 all over 1 plus 0. So, our limit 3x squared plus 2x plus 1 all over x squared plus 3, which x approaches to infinity, is equal to 3. Example number 2. So we have limit sin x over x, which x approaches to a. So let's substitute the value of x, which is a. So we have sin a all over a. So the result is 1. It is according to the rule of limit. So let's proceed to example number 3. So we have limit tan x minus sin x all over x squared tan x. So first, let's expand the tan x. So we have sin x over cosine x minus sin x all over x squared times sin x over cosine x. First, let's simplify the numerator, which is sin x over cos x minus sin x. So let's find the LCD. So the LCD of sin x over cos x minus sin x is equal to cosine x. So, cosine x divided by cosine x is equal to 1 multiplied to sin x, so we have sin x. Then, cosine x divided by 1, since this is it has a constant 1 here, so we have cosine x multiplied to negative sin x, so we have negative sin x cosine x. Then, we have x squared times sin x over cosine x, so we have x squared sin x over cosine x. After that, if we divide fraction to fraction, so we will multiply sin x or the numerator to the reciprocal of the denominator. So we have sin x minus sin x cosine x or all over cosine x times cosine x all over x squared sin x. So cancel the cosine x. After that, we have sin x minus sin x cosine x all over x squared sin x. So, to cancel out the sin x, so let's factor the numerator. So, we have sin x times 1 minus cosine x all over x squared sin x. So, cancel the sin x. 1 minus cosine x over x squared. So, if we substitute the value of x, which is 0, so we have 1 minus cosine 0 over 0. So, it is indeterminate form. That's why we will find the derivative of 1 minus cosine x over x squared. So, the derivative of 1, since it is constant, so it is equal to 0, minus the derivative of cosine x is negative sin x. Multiply to negative, so the result is sin or positive sin x. Then, the derivative of x squared is equal to 2x. Then, if we substitute the value of x, which is 0, we have sin 0 all over 0. So, it is indeterminate form. So, we will find the derivative of sin x over 2x. So, we have the derivative of sin x is equal to cosine x. Then, the derivative of 2x is equal to 2. So, substitute the value of x. So, we have cosine 0 all over 2. In our unit circle, the value of cosine 0 is equal to 1. So, the result is 1/2. So, the limit of tan x minus sin x all over x squared tan x, which x approaches to 0, the result is 1/2.